In 1610, Galileo Galilei looked at Saturn. His telescope was primitive. He wrote "Saturn has ears" in his diary. Christian Huygens realized they were not ears 50 years later. They were ring-shaped, thin, and smooth. Thus began a solar system story. It was the most beautiful misunderstanding. Instruments became more precise. Saturn resembled a wreck of destruction instead of perfection. Today, it is different. Computer simulations and probes like Cassini revealed inner workings. It has become clear. Saturn's beauty arrived after disaster. Voyager 1 and Voyager 2 flew past Saturn in the early 1980s. They sent close-up views of the rings to Earth. The photographs showed a complex structure. It was not a smooth glow. There were hundreds of thousands of concentric arcs. There were fine lines and light and dark bands. Researchers established something for the first time. What looks solid is a cluster of billions of bodies. These bodies include ice chunks the size of a recruiting office. They also include tiny dust particles, less than a millimeter. These rotate in a perfect dynamic system. The ring system's overall diameter reaches about 280 kilometers. The rings are extremely thin. They range from 10 to 300 meters. They are almost invisible in profile. Saturn's rings are divided into main structures. These have conventional designations. The D ring is closest to the planet. It is very thin and dark. Next is the C ring. It is also called the inner transparent ring. It is denser but still translucent. Then comes the bright, wide B ring. It contains most of the system's mass. It displays alternating light and dark bands. The A ring lies beyond the B ring. It is slightly less dense. The Cassini division separates them. It is up to 4,800 kilometers wide. Narrow divisions are sometimes visible. These are known as Encke gaps within the A ring. More distant rings include the narrow, dark F ring. It oscillates and fragments into arches. There are also the fainter, diffuse G and E rings. They extend hundreds of thousands of kilometers. They are composed primarily of tiny icy particles. These particles move in their own orbits. They obey the laws of gravity. They also interact with other bodies. Saturn and its moons create tidal forces and gravitational influences. These forces create complex resonances. They form gaps and arches. They hold the rings in a stable structure. The structure is constantly changing. As a result, the ring system seems fragile and perfect. It is like a cosmic mosaic. Even the smallest particle plays a role. It contributes to the dynamic balance of the whole. But where did these particles come from? Why are Saturn's rings almost pure ice? There are only traces of rock and dust. If they are so huge, could they have always existed? For a long time, the answer seemed simple. The standard hypothesis stated the rings are remnants. They are from the same material as moons. Saturn formed 4.5 billion years ago. It was surrounded by a disk of gas, dust, and ice. This material should have coalesced into moons. Some remained in a specific zone. The planet's gravity prevented the bodies from coalescing there. This explains the ring's location. They are within the Roche limit. This is where the planet's tidal forces are strongest. They are stronger than the gravity of the particles. Moons aren't born there. They disintegrate. This hypothesis persisted for decades. It was logical and simple. As happens in science, it was wrong. Doubts first arose when researchers saw how bright the rings were. Their reflectivity is high. Their albedo is almost like pure snow. The material reflects about 90% of sunlight. It reflects sunlight before turning yellow. If the rings were billions of years old, they would have darkened. Micrometeorite dust, radiation, and aging ice would have caused this. Saturn is far from the Sun. Over billions of years, the rings should have become dark debris. They still shimmered. This was strange and suspicious. Data changed this from the Cassini mission. Cassini orbited Saturn from 2004 to 2017. The spacecraft conducted dozens of flybys. It measured the ring's mass and composition. It measured the rate of contamination. It measured the rate of particle rain falling onto the planet. The mission had a grand finale. Cassini dove between the rings and the atmosphere. The instruments recorded the ring material. It was almost chemically pure ice. There were no signs of ancient erosion. If the rings were ancient, they would have accumulated dust. Tens of grams of dust would exist for every kilogram of ice. Observations showed that contamination does not exceed 1%. This means something. Either the rings are very young or they have a self-cleaning process. One hypothesis exists. The rings formed recently. They formed between 100 and 400 million years ago. Humanoids still roamed Earth then. Another idea is that the rings may be ancient, but they are constantly being renewed. Old particles fall. New ones are ejected from destroyed satellites. This year, models used supercomputers. They showed that if icy satellites collided, their mantles could have ejected debris. Some debris ended up outside stable orbits. This debris stretched along orbital lines. It collided and began to fragment. The rocky cores of the satellites fell. They fell back to the planet or formed new moons. The lighter ice remained at the Roche limit. It could not fuse back into a body there. This is how the rings were born. Possibly, this also created icy satellites we see today. This helps understanding the system. Rings and moons are not separate worlds. They are parts of a single process. Destruction of some bodies leads to the birth of others. Computers can calculate gravitational interactions. They calculate interactions with millions of bodies. The precision was unachievable previously. Saturn's new history came to life on screens. Researchers ran simulations. They created digital reconstructions of ancient catastrophes. Icy moons collided, fragmented, and disintegrated. These virtual experiments were conducted with high accuracy. They demonstrated a likely scenario. A satellite's destruction is almost inevitable under specific conditions. One simulation showed this. 2 satellites intersected. Each had a radius of approximately 500 kilometers. These bodies were the size of Dione and Rhea. They orbited where Saturn's tidal forces stretched them. Simulations showed something upon impact. It happened at a few kilometers per second. The icy shells of these satellites evaporated. They evaporated in streams of debris. The denser rocky cores sank deeper into the planet's gravity. Billions of tons of ice were ejected. The ice went into orbital space. Within hours, the digital model showed a disk. It was forming around Saturn. It was dense, glittering, and unstable. This is how the rings formed. In every simulation, the debris concentrated. It concentrated within the Roche limit. Saturn's gravity is stronger there. It is stronger than the cohesion of the satellite material. This is a natural filter. It separates what becomes moons. It separates what becomes dust. Modern Cassini data fit this picture. The spacecraft concluded its mission in 2017. It flew between the inner edge of the rings and Saturn's atmosphere. It was the last time. Its instruments recorded a stream of particles falling. There was water ice, organic matter, and grains of silicon. This ring rain was thousands of times more intense than expected. The rings were evaporating. They were evaporating before our eyes. NASA estimates Saturn is losing material. It is losing about 20 tons every second. If this rate continues, the rings will disappear. They will disappear in 100–200 million years. This matched the age predicted. It matched the simulations of the destroyed satellite. It seemed Saturn's rings and demise are a cycle. A catastrophe created them. They are still experiencing its aftermath. One of the most debated hypotheses emerged. It was about a lost satellite. It was chrysalis, or cocoon. A catastrophic event likely occurred 150 million years ago. It radically changed the Saturnian system. This icy world was approximately 700 kilometers in diameter. It was slightly smaller than modern satellites. It orbited Saturn at a distance. The distance was approximately 150,200 kilometers. Orbital velocities reached 15–20 kilometers per second. The Moon's orbit became unstable over time. Tidal interactions occurred between Saturn and its moon. Titan gradually drifted away from the planet. This altered the system's gravitational balance. Chrysalis began to deviate from its previous trajectory. Its orbit became more eccentric. It came too close to Saturn. The cocoon reached its limit of stability. The planet's forces tore it apart. Some debris fell onto Saturn. Much of the material remained in orbit. Icy and rocky particles formed the rings. They are the bright rings we see today. This explains why Saturn's rings are young. Simultaneously, the motion parameters of the other satellites changed. Titan's orbit became more elongated. Saturn's rotation axis acquired its current tilt of 26.7 degrees. The destruction of Chrysalis had effects. It created a decoration for the planet. It altered the entire dynamics of the system. Its name was symbolic. A cocoon transforms into a butterfly. The destruction of this satellite revealed the beauty of the rings. It became a spectacular event. It was in the solar system's history.